The Poisson distribution function returns the value of the Poisson probability mass function, or the Poisson cumulative distribution function for a specified value of x and mean lambda. We will also use the exponential form of the Poisson probability mass function, which also generates the bell curve, and we'll calculate the area under the bell curve using the area under each segment of the bell curve. So the bell curve is cut into 15 segments, and the area is 1 times the length of the Poisson's probability mass function. So our lambda will range from 1 to 15. So data validation, and the list will be from 1 to 15 and save. Now we have a choice of lambda from 1 to 15. So we decide on, for now, we decide on 6. Then we generate the Poisson probability mass function, which is array formula. Poisson of the values of x and lambda. And last argument is 0 because this is a probability mass function. And we have the bell curve. We use the exponential form to generate the bell curve. So we use exponent minus lambda times lambda to the power x divided by x factorial. And we lock the reference lambda as we copy this formula for the entire column. So we have the equivalent of the bell curve. Let's start from here. So we have a portion, that's the area under the bell curve, half of the area. And then we go further. So that's the total area under the bell curve. Next, we generate the Poisson cumulative distribution function, is array formula of the Poisson of x values for value of lambda, the mean, and 1 because this is a cumulative distribution function. So this is the bell curve. Then we estimate the area. So this is equal to, if this is a condition where if this is 0 or empty, then the area is empty. If not, it is sum of this range upwards, sum of the 3 segments. And we lock the reference of the first segments as we copy the formula to the rest of the column. So we can copy that and copy the rest of the column. So if you allow only one segment, so you have an area. So we drag this a little bit. So at 3, you have 3 segments, and the total area under the bell curve, the shaded area under the bell curve is 0.148725, which is the approximate, but the value for that in Poisson is 0.151. So this is a very good approximation. As we go further, the area under the bell curve is 0.91, which is also 0.91 for the value of the cumulative distribution function. This shows that the cumulative Poisson cumulative distribution function measures the area under the Poisson probability mass function. So we go further. Now the total area is 0.997.99. So this is an approximation of the Poisson probability or cumulative distribution function. We can change our lambda to 4. This is our lambda. There's just slightly difference because this is an approximation. You can change our lambda to 12. And that's our lambda. So it's 12. And this is the area. This measures the area under the bell curve. This completes the comparison of the Poisson probability mass function and the Poisson cumulative distribution function.